And we're live. Welcome everyone to Grockit's OGTV. That's Official Guide Television, like it says right here, Official Guide Television. This is the GMAT edition of our Official Guide Television show where we go through the official guide to the 12th edition to the test, the 12th edition to the GMAT test. We have different editions of the Official Guide TV for different official guides for different tests. This one's the GMAT. And what we're doing is we're going through the entire official guide. That's the 12th edition with the kind of purple cover. And we're going question by question, page by page through the whole thing, giving you the answers and answers as well as the explanations. And of course, there are answers and explanations in the book, but sometimes there's a difference between the way you read it off a page and the way someone explains it. Also, I don't necessarily use the explanation that's in the book exactly as written, so the way that I explain it may give you additional insight. You may be studying, just beginning your program of studying, and so you are just embarking on your adventure through the official guide. I personally don't think anyone should study for the test without the official guide because, I mean, it's made by the makers of the test from things that they've done in previous versions of the test. The things that they think are important for you to know are in that book. And so you may be at the very beginning where you haven't actually cracked the book open yet and you just want to have someone guiding you through the process. You may also have been studying for a while and you've run into some problems where you've done it, maybe you sort of get it, or the explanation just doesn't quite make sense to you, and so you're interested in hearing another explanation. And of course, the nice thing about video in this format is that you can have the book open in front of you while someone is talking to you. So you don't have to flip back and forth to the answers and explanations as you're working through it on your own. There are a lot of problems in the book. The first section that we go through is the diagnostic test at the beginning. It's not part of the main explanation proper, but in that section there's 24 problem-solving questions, there's 24 data sufficiency questions, and then 17 each of the reading comprehension, critical reasoning, and sentence correction. Then once you get to the main section of the book, there are 230 problem-solving questions. There are 174 data sufficiency questions, then 139 reading comprehension questions, 124 critical reasoning questions, and 140 sentence correction questions. And if you've been doing the math at home, if you pause the video to see how many that is, by my count it ends up being 906 questions in the official guide that help prepare you for the test. And we'll be going through all of them together. I'll be going through them regardless of whether you watch, but if you watch these broadcasts, you too will be going through them, and so we'll be doing it together. And that's what I mean when I say we go from cover to cover. We do the whole thing, all 906. And I mean, of course, the show would still be good without that, but I think thoroughness is best. And that is a lot of questions, and this is the other reason why, of course, I advocate the use of the official guide in any program of study, is that it's a lot of questions by the test makers themselves. So, without further ado, let's get started on that diagnostic test. That's this section over here. This is the diagnostic. You can do these, I have to spell diagnostic right. You can do these separately to get a rough idea of where you are. I personally recommend doing a full-length practice test, a full-length timed practice test as more of a diagnostic, and just use these as additional questions. But if the official guide is all you're using, by all means use it as a diagnostic. So we'll be starting with that on page 20. So that's actually how we track these. In the upper corner of the page, upper corner of the screen, I'll tell you what page we're on. So we start on page 20, and we start with question number 1. We have the answer choices already written out, but because I have to kind of write this out manually for each question, I still have to write down what the answer choices are. So that takes me a little bit of time, and it depends on how long the answer choices are. So this one's a little bit longer. So I write down all of the answer choices so that I can point out various elements of what's going on with them, also so that you know which question I'm on, because the rest of it, I don't write out the whole question, just the answers. So B plus 1595, 5 times $4 plus $16. And of course I do this a little bit differently when we get to the data sufficiency section. On that one, I don't write out the answer choices since those are the same for every question. It works a little bit differently. And also when it comes to the verbal section, it's not really worth it to spend that much time writing out answer choices. The idea is that you have the book in front of you when you are doing or paying attention to these broadcasts. 4 minus 0.01 plus 1590. And 5 times 4 minus 0.05 plus 1595. The next thing I do is just read the question, and so that's what I'll do. Last month, a certain music club offered a discount to preferred customers. After the first compact disc purchased, preferred customers paid $3.99 for each additional compact disc purchased. If a preferred customer purchased a total of 6 compact discs and paid $15.95 for the first compact disc, then the dollar amount that the customer paid for the 6 compact discs is equivalent to which of the following? So when you get something like this, your first step is always going to be to try to convert the words of the question, and this is true whether it's problem solving or data sufficiency. Try to convert the words into algebra or at least math. We won't always have to do algebra, but sometimes just converting it will make it a lot clearer. So in this case, the person pays $15.95 for the first disc, and then they pay $3.99 for each disc after that. So that means the person is paying, there are 5 discs after the first one because it's 6 discs total, 5 times the price of $3.99. And it looks like everything in the answer choices has it in the reverse order, so it's 5 times $3.99 plus $15.95. Perhaps to our dismay, we look over at the answer choices and see that absolutely 0 of the answer choices have it in this format. And it's not because we've done something wrong, it's because there's some rounding going on in each of these answer choices. So each of these parts has been rounded, so the first answer choice has 5. All of them have some multiple of $4 when it's actually $3.99 for real. And then there's some other estimation of the other dollar amounts. So we need to figure out which one still represents the exact same amount. A good way to do this is to look at how much over or under each of these estimations is, and they should be equal to what this is. Let me give an example. So let's just start with one that looks more obvious. Start with answer choice E. So 5 times the quantity 4 minus 0.05. That equals $3.95. And we already know that each of the extra compact discs is actually $3.99. So this is 4 cents short per compact disc. So the first part of this expression here is actually 20 cents short. The second part, $15.95, is the exact amount. So this one's the same. But if the whole thing is 20 cents short, it can't possibly be an approximation of the thing that we figured out, namely this guy here. The next one, 5 times the quantity 4 minus 0.01, this is the same thing as 5 times $3.99. 1 penny from $4 is $3.99. And 5 times $3.99 is what we have for the first part, so this one's the same in the first part. However, the second part is $15.90, and from our calculations, which weren't really even calculations, it actually comes out to be $15.95. So this one is 5 cents short also. I shouldn't say also, the first one wasn't 5 cents short, the first one was 20 cents short. The total thing is 5 cents short, and these both need to come out to be the same. So this one, choice C, 5 times $4, instead of 5 times $3.99, that ends up being 5 cents over. But this could be okay if the second part compensates. But instead, there's $16 in the second part instead of $15.95. So this one is actually 5 cents over in each part. Again, 5 times $4, we established that that's plus 5 cents. and then 15.95 is the same. So the net is that it's 5 cents over. So of course, by process of elimination alone, that allows us to say answer choice A must be the right one, and it is. But let's just show 5 times $4, that's 5 cents over. But then 15.90 is 5 cents less than the 15.95 that we figured out. So it's minus 5 cents here. The two cancel each other out, and it is in fact the same price. Answer choice A is the correct one for number 1. So that's how we'll be going through the problems, question by question, page by page, cover to cover. And yeah, I guess I don't have that much else to say about it other than let's move on to question number 2. So, of course, we're going to stay on page 20 for a little while. There's several questions on this page. And here we have some shorter answer choices. It won't take me quite as long to write these out. 150, 175, 200, 225, and 300. Okay. So the average, or arithmetic mean, of the integers from 200 to 400 inclusive is how much greater than the average of the integers from 50 to 100 inclusive? So the integers from 200 to 400, and then we have the integers from 50 to 100. So an important thing to remember about consecutive numbers, so let's go with 1, 2, 3, 4, 5. So if you have consecutive integers, the average, and actually let's just do for comparison, 4, 5, 6. When you have an odd number of numbers of consecutive integers, the middle one is going to be the average, because for every 1 that you go up on the other side, you go down on the other side, keeping the average the same. When you have an even number of numbers, that's why I've written out 1 through 6, the average is actually the average of the two middle numbers. So which is it when we have 200 to 400 and 50 to 100? A good way to think about this is the numbers from, actually I was going to say 0 to 10, but that might be confusing. Let's do 10 to 20. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So even though the difference between 10 and 20 is 10, you will note that there are 11 numbers there. There's an odd number of numbers. So this is an important lesson for the GMAT, and one that they actually test at least a couple times, even in the official guide, so you know this is important to them. That the difference between two numbers is not necessarily the number of numbers between them, inclusive or exclusive. If we had been 10 to 20 exclusive, it still would have been these numbers here. So instead of 11 numbers, there would have been 9. So just the important thing to remember, whether you're counting inclusively or exclusively on both ends, the number of numbers is not the same as the difference between the two. So what this means is that there's an odd number of numbers here and an odd number of numbers here. That makes it a lot easier for us because it just means it's the middle number. The middle number between 200 and 400 is going to be 300. The middle number from 50 to 100 is 75, the one that's 25 from each end. So, like here we had plus 25, and here we had minus 25. Same thing with here, there's 100 on either side, making that the average of each of those sets. The question is ultimately asking us then, what's the difference between those two averages? We do 300 minus 75 equals 225. Answer choice D. Still page 20, and now we're on question 3. 12, 16, 20, 24, and 28. So the sequence a sub 1, a sub 2, a sub 3, all the way to a sub n is such that a sub n equals a sub n minus 1 plus a sub n minus 2 divided by 2 for all numbers where n is greater than or equal to 3. If a sub 3 equals 4 and a sub 5 equals 20, what is the value of a sub 6? So we have some numbers that we're going to need to keep track of. We have a sub 3, a sub 4, a sub 5, and a sub 6. And really what this is saying, if you were kind of looking past the formula, looking beyond all the crazy subscripts and stuff like that, is that any number in this sequence is equal to the average of the previous two numbers in the sequence. That's what, so, if n is 6, or 10, the 10th number in the sequence is the average of the 9th number and the 8th number, or it's the taking the 9th number and the 8th number and dividing that by 2, which is the same thing as the average of those two numbers. So, and we know that a sub 3 equals 4, and a sub 5 equals 20. And the question is, what is a6? Now, to figure out a6, we can just use the formula. a6 equals a5 plus a4 over 2. Now we have a5, but we don't have a4, so we have to figure out what that is first. We get to do the formula twice, basically. We do know that a5 is 20, so we're going to use the other formula first. I'm going to start that down here. A sub 5 is, formula-wise, going to be the 4th number in the sequence plus the 3rd number in the sequence, those are the previous two numbers, divided by 2. Now we know what some of these numbers are. A5 is 20. We don't know what A4 is. But we do know A3 is 4, and that's divided by 2. So 20, we'd multiply both sides times 2, actually. So 40 equals A4 plus 4, and A4 equals 36, and now we're getting somewhere. Now that we have 5 and 4, we can figure out what the 6th number in the sequence is. So we plug in those up here. A5 is 20, A4 is 36, divided by 2. So 20 and 36 is 56. That equals 56 divided by 2. And 56 divided by 2 equals 28. Answer choice E. So very often, it's very important not to get too lost when they throw one of these formulas at you. A lot of times all it takes is substituting the numbers that they give you into the formula, and all of a sudden it's just a relatively simple matter of arithmetic, even though it doesn't look like that at first. So I think the number one skill when it comes to formula type questions is not panicking. All right, on to the second column on page 20. Page 20, question number 4. So we have 9/50ths, 7/25ths, 7/20ths, 21/50ths, and 27/50ths. So among a group of 2,500 people, 35% invest in municipal bonds, 18% invest in oil stocks, and 7% invest in both municipal bonds and oil stocks. If one person is to be randomly selected from the 2,500 people, what is the probability that the person selected will be the one who invests in municipal bonds but not in oil stocks? A couple things we need to remember here. Two formulas really that end up being handy, one more so than the other. The big one's probability. I guess I'll put that over here. Probability is always expressed, well, not always, but probability is generally expressed as a fraction from 0 to 1 inclusive. Something that has a probability of 0 has no chance of happening. A probability of 1 has a 100% chance of happening. Usually it's between the two. And we represent that by the desired outcomes, or the things that you're trying to figure out what the chances are of that happening, even if it's something you don't technically desire, like getting stomped on the foot. So the desired outcomes out of the total outcomes is the probability fraction. The other thing to keep in mind is our issue with overlapping sets. And this comes up fairly often on the GMAT, so it's good to kind of have this in mind. When it's only two sets, it looks a lot like a credit card logo, where you have one circle and another circle. We have the overlap of the two, and then sometimes we have a group over here that's not in either circle. And the total for all the people in that group is A plus B minus both plus those that are in neither group. How does that matter for this question? Well, it matters a little bit less because we do still have overlapping sets. So now we're really on question 4. We find out that 35% invest in municipal bonds. So we'll put the 35 out here because it's not the 35 that only invest in municipal bonds. If we were doing the 35 that only invest in municipal bonds, that would be this amount, not including the both, and it would have had the word only in it. So this is the full circle. The full circle includes 35. 18% invest in oil stocks, and 7% invest in both municipal bonds and oil stocks. So we have the 7 here. What this tells us, of course, is that then it's 11 here and 28 in here. And this is the part we're concerned with over here. We're interested in the part that are in municipal bonds but not in stocks. And remember, these are percent. So this is 28%. 28% of the original 2,500, so 2,500 times 0.28, if you're doing that math, it comes out to be 700. So then our question is what the probability is of getting one of these people out of the total. And remember our probability fraction here, desired out of total. 700 are the desired outcomes, 2,500 are the total outcomes. We can simplify, divide by 100, numerator and denominator by 100, and we get 7/25. That's a 2. Answer choice B. Okay, last one on the first page, which is page 20. Question number 5. So we have 2, 3, 4, 6, and 9. A closed cylindrical tank contains 36 pi cubic feet of water and is filled to half its capacity. When the tank is placed upright on its circular base on level ground, the height of the water in the tank is 4 feet. When the tank is placed on its side on level ground, what is the height in feet of the surface of the water above the ground? So, time for some art. So we shall imagine that this is our circular tank, or cylindrical tank, and when it's on level ground, standing on its circular end, the volume of the cylinder goes up. It's 36 pi cubic feet, and the height of the water is 4 feet off the ground. So the question is then, what happens when this same cylinder is turned on its side? Okay, that didn't come out quite right, but you know, whatever. Okay, so one of the key things to realize here is that something that's half full is going to be half full no matter which side is on the ground. So it's going to be exactly half full of water here. Maybe I should, oh, I don't have blue anymore. Never mind. We can make it green water. That's pretty cool. Okay. So what this means is, since this is exactly halfway, it's also the center of the circle. So the height off the ground of the water in the cylinder on its side is equal to the radius of the circle, if we can figure out what that is, because it's going to be halfway no matter what. So, of course, one of the things that's absolutely essential to this is realizing that the volume of a cylinder is pi times the radius squared times the height of the cylinder. Basically, it's the area of a circle times the height of the cylinder. And we have that volume. So the volume of the cylinder was 36 pi cubic feet, and that equaled pi times the radius squared times the height. First thing we want to do is divide by pi, get that out of here. So 36 equals r squared times the height. And we can also use the height of the cylinder over here when it was vertical. And so there it's 4. So 36 equals r squared times 4. Divide both sides by 4. R squared equals 9. So r equals 3. So the water, the green nasty water of our cylinder over here is 3 feet off the ground when it's on its side and 4 feet off the ground when it's vertical. Answer choice B, 3. Yeah, you may also note that 4, one of the trap answers, 4 is the height here. The height does not stay the same. And then also 9 here, that equals r squared. So someone may have actually stopped at this point and said, oh, you know, that's probably the right answer. And of course it's not. We need to solve for r, not for r squared. So choices C and E are traps meant to catch people who don't go all the way through the problem. Anyway, on to question 6, top of the next page. So page 21, question 6. 15, 20, 30, 40, and 45. A marketing firm determined that of 200 households surveyed, 80 used neither brand A nor brand B soap, 60 used only brand A soap, and for every household that used both brands of soap, 3 used only brand B soap. How many of the 200 households surveyed used both brands of soap? So once again, we're using our overlapping sets here, and again in kind of an interesting way. We're given a lot of information to begin with. So we have total equals 200. We have a group over here that uses neither. We have A and B. Okay, so 80 use neither. We have 60 using only brand A. And note that the word only is in there, so I draw them inside the circle to differentiate them from those who are just the entire circle, which includes those who do both. And for every household that uses both, 3 use only brand B. So for every 1 here, we use X. There are 3 in here, and we represent that as 3X. Now, since we have the total, it's actually not going to be too hard to figure out what X is. And X is what we're after. The question is asking how many of the 200 households surveyed used both brands of soap. So X equals both. So when we're figuring out our stuff here, we can basically subtract those who are doing neither. So 200 minus the 80 equals 120. So everything here, everything in this part of the drawing is 120 people. So 60 plus X plus 3X, these 3 individual populations, those equal the 120 people who are using one or both of brand A and brand B soaps. 4X plus 60 equals 120. 4X equals 60. We subtract 60 from both sides and divide by 4. X equals 15. So since X was what we were after, that's the number who are doing both. That's right out answer choice A. If someone solved for the wrong thing and solved for 3X, that's the trap answer here. I don't know where the other ones come from, but there aren't always obvious trap answers. They're just counting on some minor errors in computation. Anyway, answer choice A it is. On to page 21, number 7. So we have 1/720th, 1/80th, 1/10th, 1/9th, and 1/5. A certain club has 10 members, including Harry. One of the 10 members is to be chosen at random to be the president, one of the remaining 9 members is to be chosen at random to be the secretary, and one of the remaining 8 members is to be chosen at random to be the treasurer. What is the probability that Harry will be either the member chosen to be the secretary or the member chosen to be the treasurer? So, some key elements here. Once again, our probability fraction equals the desired outcomes over the total outcomes. two other key rules of probability. When you're trying to figure out the probability of a sequence of outcomes, this happens, then this happens, then this happens. Probability of a sequence, you multiply the probabilities. When you're trying to figure out which one of several alternatives, probability of alternatives, so it's not both things happening, it's one or the other, you add the probabilities together. So let's see how that applies to Harry and his election campaign. First thing we need to know then, so his probability then will be the probability, the thing we're ultimately trying to figure out is his probability of being secretary plus the probability of his being treasurer, because these are the two alternatives that we're trying to figure out. So this plus this will equal our answer. We have to figure them out individually, though. I'm going to make a line here so that our space does not get interrupted. Okay, so the probability of being elected secretary. So in order for Harry to be elected secretary, he needs to not be elected president. So there are 10 people in this certain club, so the president has a 1 in 10 chance of being elected. I'll do that down here. The chance of being president is 1 in 10, and in fact we can actually do the probabilities of the other things. The probability of being elected secretary is 1 in 9 because one person has already been selected as president, and then the probability of being selected treasurer, it's one of the remaining 8 people, so that person has a 1 in 8% or 1 in 8 chance of being elected treasurer. However, we need Harry to not be elected president in this case. So if there is a 1 in 10 chance of being president, there is a 9 in 10 chance of not being chosen president. So that's 1/10. Oh, excuse me, 9/10. But then we want him to be elected secretary, so we have to figure out what that is. We know that that's, yes to secretary. We have established down here that the probability of being secretary is 1 in 9 because one person has already been chosen. And the probability of this sequence of things happening, Harry not being chosen as president, but then definitely being chosen as secretary, we multiply the two probabilities together. 9/10 times 1/9 equals 9 over 90, or if you cancel out the 9s, either way it simplifies to 1/10. So the probability of being secretary is 1/10. Let's figure out what the probability is of being treasurer. So he still has to be not president. 9/10 chance of that happening because he has a 1 in 10 chance of being that. But this time we need him to not be secretary either. He needs to still be available for the election as treasurer. No secretary. So this one is, if he has a 1/9 chance of being elected, he has an 8/9 chance of not being elected. But then we want yes to treasurer, and he has a 1 in 8 chance of that happening. So we multiply these all together. It is easiest to cancel out things this way, so that then you are just multiplying the numbers that are left, and that equals 1/10 again. So the probability of that is 1/10. And then we just add our two probability fractions together. 1/10 plus 1/10 equals 2/10, which also equals 1/5, which is answer choice E. So you can see where some of the other trap answers come in handy. This is the probability of just being secretary. This is the probability of being president. 1/80th, I guess this was the chance of I'm not sure where they come up with that. I mean, that's probability of being president and treasurer, I guess. And then of course choice A, 1/720th. They just this answer choice was calculated by multiplying 1/10 times 1/9 times 1/8. That's his chance of being elected to all three offices. If he could somehow be removed from the running for each thing and still be in the running for each thing, like if he, I don't know, in being elected to one of the offices kicks one of the people out of the club or something. Anyway, these are all terribly wrong traps, so don't pay attention to those. We got answer choice E and we are right. Okay, number 8 on page 21. Our choices are 1/4, 1/2, 2/3, 2, and 4. So if a certain toy store's revenue in November was 2/5 of its revenue in December, and its revenue in January was 1/4 of its revenue in November, then the store's revenue in December was how many times the average, aka arithmetic mean, of its revenues in November and January? Wow. Well, so this one is clearly an exercise in converting words to algebra. Let's just start with them and take them in order, actually. That's usually the easiest way to go. First, we find out that the revenue in November was 2/5 of the revenue in December. So November revenue was 2/5 of the December revenue. We also find that the January revenue was 1/4 of the revenue in November. Okay. Then the store's revenue in December was how many times the, okay. So let's get both of these in terms of December then. That will make life easier. So if January is 1/4 of November and November is 2/5 of December, January is J equals 1/4 of that value for November, namely 2/5 of December. And we can multiply across. We get 2/20ths or 1/10. So January was 1/10 of December, and November was 2/5 of December. So then the question is, how many times is December's revenue is how many times the average of November and January? So next we need to figure out the average of November and January. You may remember that the average is the sum of the numbers that you're adding up over the number of numbers. If you don't have that one committed to memory, that's one of the first things you should commit to memory. The average formula is something you can't do without even in real life. So the average of the two, so the average of November, which is 2/5 of December, plus what they happened in January, which is 1/10 of December, and we divide by 2 because there's two different numbers. We can do a little conversion here. Let's turn them both into tenths. So we have 4/10 of December plus 1/10 of December over 2. We can rewrite it again as 5/10 of December over 2. And 5/10 is the same as 1/2, so it's 1/2 of December over 2. And 1/2 divided by 2 is the same thing as 1/2 times 1/2. 1/2 December times 1/2 equals 1/4 of December. So the average of November and January together is 1/4 of December's revenue. Now, if those two are 1/4 of December, then December's equals 4 times the average of November and January. So if these guys are 1/4 of this guy is 4 times that. That's a reciprocal relationship. That gives us answer choice E, which is 4. Let's do a few more. Still page 21, question number 9. All right. So mean only, median only. standard deviation only, mean and the median, and then mean and standard deviation. Okay. So, a researcher computed the mean, the median, and the standard deviation for a set of performance scores. If 5 were to be added to each score, which of these 3 statistics would change? So this is really hinging on your understanding of the definition of these things. So we have the mean, the median, and the standard deviation. We'll start with the easiest one first. The median is the middle number. Let's just choose 2 different sets of numbers here. Actually, let's just choose 1 set of numbers and just keep it easier. 1, 2, 3, 4, 5. Let's pretend those are the performance scores. The middle number, if we added 5 to it, if we added 5 to all of these numbers, the middle number is still going to be the middle number. So this will be 6, 7, 8, 9, and 10, but it's not the same number. So if you add 5 to an entire set of numbers, every one of them is going to be different, including the median. It'll be in the same place, it'll be in the middle, that's what the word median means, but it's going to be a different number. 3, I probably don't even need to say this out loud, 3 is not the same number as 8. So the right answer definitely needs to include the median. We could cross off A, we could cross off C, and quite frankly, we can cross off E. Our only choices are the median only and the mean. Let's see what happens to the mean. So remember, let's use our same set of numbers. 1, 2, 3, 4, 5. And they need not be consecutive, but this applies to even when the numbers are not consecutive. The average in this set, in this case, is actually going to be the middle number. I think we covered this already in this broadcast that for every 1 you go up, you also can go down 1 on the other side. So the middle number is the average, and mean is the same thing as the average. If there's an even number of numbers, it's the average of the 2 middle numbers. I didn't do that here. If we add 5 to all these scores, 6, 7, 8, 9, 10, the middle number, the average, it changes. It's in the same place again, but it's a different number. So clearly answer choice D is the right answer. The mean and the median will change. Let's talk briefly about standard deviation. You don't usually have to do anything close to calculating it on the GMAT, but every once in a while it is important. And in higher end questions, you may need to know a little bit more about how to calculate it. Mainly what standard deviation is a measure of, not mainly, this is what it is. It's the average distance of the numbers in a set from the average of the set. So the further apart the numbers are, the more unevenly spaced they are, the more the spread of the numbers, like these 2 numbers are 100 apart and then the other 2 are only 3 apart, that's going to have a larger standard deviation than a number where all the numbers are evenly spaced. Does that make sense? So with a number set like the one we've been using in this problem, where the numbers are all 1 apart. Now they're not all 1 from the average of the set. There's a distance of 1 here, but then there's a distance of 2 here. If you figured out the standard deviation, it's going to be between them. However, adding 5 to every number in the set does not change the distances involved from the average in the set. So the relationships between the numbers stay the same, and since the standard deviation is not going to be a number in the set, that relationship is maintained. And so the standard deviation would not change by adding 5 to each number. Okay, second to last one. So page 21, last one on page 21 anyway. Question number 10. So 45, 90, 180, 270, and 360. It's time for some art. In the figure shown, what is the value of v plus x plus y plus z plus w? Yikes. All right, so I'm going to draw this fairly big. And hopefully fairly straight. All that's important is that you get the idea, though. So we have x y, z, and then v and w there. And we want the value of v plus w plus x plus y plus z equals, who knows what that equals? They did not give us among the answer choices it cannot be determined from the information given, so there must be a way. So a couple things that are really useful to know about this one. One is a formula that, if it weren't cheating, you would want to have tattooed on your arm. And that's that the sum of the angles in a polygon is equal to n minus 2, where n is the number of sides, times 180. So a triangle, for example, which has 3 sides, 3 minus 2 times 180, a triangle has 180 degrees. A square, or any sort of quadrilateral of that kind, would have 4 sides. 4 minus 2 would have 360 degrees. And if you think about a perfect square, that would be 90 times 4. But of course, it doesn't have to be that. Anyway, very useful formula. The other thing we can do with this problem is kind of look at it and see this as a series of overlapping triangles. I'll just draw a couple of them here. So we're probably going to need some, well, let's just do one of these first. So just imagine that this is a triangle. I mean, it is a triangle, but just kind of cast your gaze upon that one. And then you can also just imagine that, for example, this is a triangle. And you can do that for every one of the interior angles on the pentagon in the middle. You can make that the vertex of one of these triangles. I don't have enough colors, actually, to draw all of them, but you get the idea. So we do need to give names to these. So let's just name these guys A, B, C, D, and E. And remember, the sum of the angles in a triangle is 180. So, for example, if we use the red triangle that I just drew, we would have A plus W plus Y equals 180. And we can do that for the other ones too. So we have the triangle BVZ. B plus V plus Z equals 180. The one that has C at the front is CX and W. And we have one that's D at the vertex, so that's CV and Y, or DV and Y. And then last but not least, we have E at the green triangle, which is E plus X plus Z. What good does this do us? We can add this whole thing together, which is nice. It's going to be kind of long. So A plus B plus C plus D plus E. And then you'll note that each of the other 2 points in the triangle appears twice. So W appears here and here. V is here and here, X is here and here, Y. Every one of them appears twice. So it's plus 2V plus 2W plus 2X plus 2Y plus 2Z. And 180 times 5 equals 900. Do not despair, because the other thing we realize is that this is a pentagon in the middle here. A, B, C, D, and E add up to the number of angles in a polygon. So 5 minus 2, is 3 times 180, which equals 540. So this means these guys added together on their own equal 540. And all of a sudden it becomes a much simpler equation. We'll just write that back up here with what we know. So 540 plus 2v plus 2w plus 2x plus 2y plus 2z equals 900. Of course, we need to subtract 540 from both sides. So 2v plus 2w plus 2x plus 2y plus 2z equals 360. And we can divide everything by 2 because there's 2's all over here and 360 is divisible by 2. So v plus w plus x plus y plus z equals 180. So now we know the value of the very thing that the question was asking for. Note that we don't have to solve for any of those individual angles. We just have to know what their sum is, and their sum is answer choice C. All right, this will be our last one for this session, now that you've gotten the idea of what all this is about. So this is page 22, question number 11. And our choices are 90, 82, 80, 45, and 36. So of the 3-digit integers greater than 700, how many have 2 digits that are equal to each other and the remaining digit different from the other 2? Wow, okay. So there are 3 ways that you can have a 3-digit number with two digits that are the same. I have to talk more slowly apparently. 2 digits that are the same and 1 digit that is different. You can have them in the format, these 2 are the same and this one's different. You could have them, the 2 on the ends are the same. Or you can have the one different one be the first digit. So examples of our, in our 3-digit numbers greater than 700, these would be, this set would be things like 880, 881, 882, all the way to 889. But it's worth pointing out, no 888 because it doesn't have one of the digits different. Ones in this format would be 808, 818, 828, all the way to 898, but still no 888. Last but not least, these guys here would be 800, 811, 822, again all the way to 899 with no 888. So what does this mean with no 888? So it means that in the set x, x, y, so remember, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Those are 10 possible digits. And in every case, we have to cross out one of the digits because it ends up being the same as the other one. In the case of the 8s, it's, we cross off 8. So instead of, so there's 10 possible digits for the one that's different. 10 possible digits for any one of these numbers, only 9 possible 3-digit numbers in each case because the 10th digit would be the same as the one that's doubled. Does that make sense? So when we add up all the different choices, 880 to 889, that's 10 choices. When we subtract 888, it's 9 choices. So the XXY has 9 choices, XYX has 9 choices, and YXX has 9 choices. The numbers are all, of course, way bigger than that in our answer choices. That's because we need to take into account the 700s, the 800s, and the 900s. The 900s all work this way, so there's, we have XXY, XYX, and YXX. So the 900s have 9, 9, 9. The 800s have 9, 9, 9. And the 700s, and this is really where the trick comes in, they have 9 in this format, and they have 9 in this format, but they only have 8 here because the original problem actually says the 3-digit integers greater than 700. So in this set here, when we're dealing with the 700 numbers, we have, 711, 722, all the way to 799. What we don't have is no 700, and we don't have no we have no 777. So that's the big trick on this one. So 1, 2, 3, 4, 5, 6, 7, 8. 8 times 9 equals 72, plus the additional 8 for those 700s. 80 different ways that can work out. And that's that. Answer choice C is the correct one for number 11. So I think that's where we'll stop. We'll pick up next time with or in the next broadcast with number 12 on page 22. My name is Jim Jacobson. I'll be your, oops, I had the pen off. I will be your tutor for these broadcasts, and I look forward to seeing you there, even though I won't see you. And of course, if you're watching this recorded, it's not live anyway. But I'll be there in spirit, helping you with your problems, as well as in voice and visually. So again, Grockit's OGTV GMAT edition. Welcome to it, and I hope this ends up being tremendously helpful for you. We'll see you later.